Hi there. In this video, I want to talk to you about cross product. And conceptually, what is it doing? What does cross product do? Well, cross product is a way of combining two three-dimensional vectors and getting a third new three-dimensional vector. So it's kind of like multiplication. You know, you multiply two numbers, you get a new number. Well, here you're crossing two vectors, you're getting a new vector. The only thing is, it only works in 3 dimensions. You can't do this in 2 dimensions, you can't do it in 4, but you can do it in 3. And here's what it's doing. Here's my two vectors, okay? I got vector A and vector B. All right, so I'm going to take, I got to back up a little bit. I'm going to take the cross product of A cross B. Now, what do I get? Well, what I get is I get a third vector that points orthogonally to these two vectors. So the cross product is the red pen, and it is pointing orthogonal to both of them. It's perpendicular to both of those vectors. Now, how do I know it's pointing this way as opposed to this way? Well, that is according to what we call the right-hand rule. All right, so you take your right hand, and you start at the first vector, vector A, and you spin your fingers towards vector B, the second vector. And then you stick your thumb out. That's the direction that the cross product's going to point. All right? So if I take A cross B, the cross product will point this way. A cross B, my thumb points this way. That's the direction, right? There's two possibilities, right? You can be orthogonal in this direction or orthogonal in that direction. It's got to be this way. So that's how we determine which direction it points. How about the length? What's the length of this vector? All right, well, to describe that, let's go and look at this on the computer. So let's see. Here I've got a couple vectors. So I've got my vector A over here, all right, back there. I got my vector B over here, all right? And what you see down there, that dashed line, that is the cross product. And you can see that it is perpendicular to those two vectors, right? And it's following the right-hand rule. If I took my right hand and spun my fingers from A towards B, it would be, my thumb would be sticking out in the direction of A cross B there. Okay, now, how do I know the length of that A cross B vector? Well, that's what this parallelogram is for. You see this parallelogram that's right here? So what we did is we took the vector A, and then we put at the tip of that, we put the vector B, and we took the vector B and put at the tip of it vector A. And that makes a parallelogram. Well, that parallelogram has an area. Well, guess what? The area of that parallelogram is exactly the same as the length of the cross product. So we've described everything we need to know what that cross product vector is. We've described which direction it points, and we described its length. Those are the two ingredients you need to define a vector. So now we know exactly what the cross product is. It is the vector that points orthogonal to the two vectors according to the right-hand rule, and whose length is equal to the area of the parallelogram spanned by those two vectors.